Hello everybody. I think in the last session we had seen how to do a chi-square test. And you will be remembering, if you see here, the chi-square test for independence had two variables, and the two variables were each measured using a nominal scale. Now in today's session, we will see two tests that we can do. One is a t-test for difference of two means, that is independent sample t-test, and the other one is the correlation coefficient. How to do these two tests and how to interpret the results. This is what we are going to see in today's session. If you look at the type of test, it's a parametric test. Parametric means you know by now that it should follow a normal distribution. And there are two variables in it. One variable, while it is being measured as a nominal scale, and it should have two groups only. This is the most important thing. For example, gender has only nominal scale in two groups, and the other should be an ordinal or an scale. By scale we mean here is an interval scale. And for the correlation, we will see that it is again a parametric test. There are two variables involved and both these should be measured as a scale. Now let us go and try to see, take some data and try to see how to do the test. Now in this data, you would have seen that these are related to the employee perception, and so this is one set of variables, this is another set of variables, this is third set of variables, JS is another set of variables. So what is that we will do first? The first thing that I have to do is to compute a composite score for these variables. How do we do that? If you remember, we have seen that we go to transform, compute variables. You just have to give your target variable and add up all these variables. This is what we do. Now let us come to the test that we are going to do. In this particular test, the t-test, let me assume that I want to find out if there is any significant difference in these variables, which are my study variables, based on gender. So if you see, these variables are all measured using a scale, that is an interval scale. This is how it was measured. And the test, that is our gender, is a nominal scale with two options only. So this is the condition for doing a t-test. There should be one variable should be a nominal, other should be a scale. Now let me take how to do this. Here I look at the compare means. In the compare means, you go to independent sample t-test and then your test variable. For which do you want to find the difference? Let us assume I want to find the difference in the job satisfaction. So let me take this as my test variable. And what is my grouping variable? My grouping variable, let me assume, is the gender. So this is my gender. But here you have to be careful that you have to define the groups. My group 1, what was that? Male. How do I define them? As 1. My group 2 is female. So I call that as 2. That is how the data was captured here. And then I continue. And if you want, you can look at the options that are available here. 95% confidence level. 95% confidence level means what is your level of significance? It is 5%. And I'm going to OK it. But before I do it, let us revisit it once again. There are two variables involved in this test. The independent sample t-test. The one variable should be measured using a scale, and your grouping variable, that should be a nominal scale, and it should have only two groups. Then only we can do this test. Now I'm going to OK it and I wait for the results to appear. So let us see what are the results. If you look at the results, so this is our job satisfaction and male, females, all this data is there. The mean standard deviation is there. And if I look at, where do I look? So you will find there are a lot of things which are given in the results. This is the Levin's test of equality for variances. I don't need this. Then there is a t value, there is a degrees of freedom, and there is level of significance. These are the two things that I need. I need the t value and I need whether it is significant or not. These are the only two things that I am going to see. So first thing I am going to see is this t. This is minus 2.016. Then I see whether it is significant or not. Where am I looking? Equal variances assumed. In that I will see 0.045. So is there a significant difference? You have studied that the p-value should be, level of significance should be less than 0.05 for it to be significant. So in this case, if you see this is less than 0.05, therefore there is a significant difference in the job satisfaction among men and female. But now the question is, okay, we say there is a significant difference. Can I find out who is having or exhibiting more job satisfaction? Where do I see and find out that? To know that answer, I have to look at this mean and standard deviation. So if you look at the mean values, you will find here that the females are scoring 12.6 and the male are scoring 11.8. So clearly we can know that the females are showing more job satisfaction when compared to the men. And we know that this difference between them is significant. I hope it has become clear to you. If you want, I can do one more example with another data to show you this. Let me assume that I am looking for the difference, say, in there is it doesn't have that kind of a data, so I may have to go back to this data. Let me see here itself. Now let me see, I want to find out whether in organizational commitment there is a difference. So in this, is there a difference based on yes, the same thing, gender, because only that is captured here is. So again, once again I am trying to show you compare, analyze. Compare means independent sample t-test. You have to reset everything, otherwise you won't be able to do. Then I am going to take the composite score for organizational commitment and I take gender here and then I define the groups as 1 and 2. I continue and I say okay. Now let us look at the t-test results. What are the results? Where do you see? As I told you, we look at the results here in the t value and the significance. Here you will find that it is not significant because this level of significance is greater than 0.05. So there is no difference between men and female when it compares to when it is related to their organizational commitment. Now if you want, you can also check with these mean values. You can find that they are fairly close enough. One is 14.48, another is 14.57. So these means, even when you look at them itself, you can know that it is not showing much difference. Naturally, here also the significant level is showing that there is no difference between men and female when it is related to their organizational commitment. Now let us go to the next one. I hope that the t-test has become clear to you. Let us go and try to find out how to do the correlation. So in the correlation, you will see that there is an option called as correlate bivariate correlation. Now, whatever variables you want to compare, here we have clearly seen that for doing a correlation, you have to have at least two variables and they should be measured using a scale only. So I am going to take, say, is there a relationship between their organizational commitment and job satisfaction? I am going to take both these. So for this only I am going to find out and I am going to do Pearson's correlation and options or if you want, the mean and standard deviation can be exhibited. So I'm going to OK it. What happens now, you see. This is the correlation. This is the correlation value. You will find that diagonally the values will be always 1 because it is between organizational commitment and organizational commitment. Then you look at the values which are below the diagonals. This is between organizational commitment and job satisfaction. It is 0.17 and there is a double star. A double star, it is given here, is significant at 0.01 level. So if it is showing a star, sometimes it will show a single star or it will show a double star. But just checking this value and whether it is significant. Is it significant? Of course it is significant because it is less than 0.05. So this is how your correlation values should be calculated on the SPSS. I hope it has become clear to you how to do the t-test as well as the correlation. In the next video, we will be seeing how to do the one-way ANOVA test using the SPSS. Thank you.